The major tool we're going to be using for doing calculations in Chapter 3 is what are called matrices. Matrices are a way of organizing some data, kind of like a spreadsheet, so that we can do some calculations efficiently. In particular, we'll be starting out by solving equations with matrices, and later on we'll be doing some other more involved things like finding optimum values. So let's get started by defining what a matrix is. A matrix is a rectangular array of numbers. For example, this is a matrix. Notice how there are 6 numbers here, 2, 3, 1, -1, 0, and 4, and they're arranged in a rectangular shape and enclosed with these brackets. So that's an important part of the notation to help keep things organized. So here are a few more examples of matrices. Each of the numbers in a matrix is called an entry. So for example, this 3 is an entry of this matrix. This 5 is another entry of the same matrix. Entries that are aligned horizontally make up a row. So this is a row. This is a row. This is a row. Entries that are aligned vertically make up a column. So for example, this is a column. This is a column. And this is a column. Just this number 4 all by itself is the only thing lined up vertically with itself. So that 4 is a column of that matrix. So if I talk about more than one matrix, I don't say matrices. The plural form is the word matrices. So on this slide, we can see 4 matrices. Now, when we're talking about a matrix, a lot of times we have to be careful when we're describing how big it is, the size of the matrix, and the formal term for that is called the dimension of the matrix. In order to describe how big the matrix is, we count the number of rows it has and the number of columns it has, and then the dimension of the matrix is expressed as number of rows by number of columns. So for example, this matrix has 1, 2 rows. That's where this 2 comes from. And it has 1, 2 columns, which is where this 2 comes from. This matrix has 4 rows, 1, 2, 3, 4, and just 1 column. Now notice that we have to say rows by columns. It's not true that this is 1 by 4. That's incorrect. It's 4 by 1, rows then columns. If the matrix has the same number of rows as columns, then we call that a square matrix. So for example, this matrix has 2 rows and it has 2 columns, so this is a square matrix. A lot of times we're going to represent a matrix by a letter, just like we do in algebra. Sometimes we represent a number by a letter. It's typical to use a capital letter to represent a matrix. And then if we're doing that, it's also typical to use the corresponding lowercase letter to correspond to an entry of that matrix. Like if I use the letter capital M to represent the entire matrix, I could use a lowercase m with some subscripts to talk about one of the entries. And so the notation here is to write the row number followed by the column number. So m subscript 1, 3 would mean first row, third column of the matrix capital M. For example, if this is the matrix A, capital A, I could identify the entries in this matrix. For example, this entry is in the first row, and it's in the third column. And the value of that entry is the number 5. So A13, first row, third column, is the number 5. And similarly, these are the values we get for each of the other entries in this 2 by 3 matrix.